This lesson is going to focus on solving quadratics using a different method. So far we've learned how to solve quadratics by taking the graph and looking at where they intersect on the graph. Today you're going to look at solving quadratics in an algebraic way if you're given a certain type of quadratic equation to solve. So we're going to look at some examples. But what we're going to do today is we're going to solve quadratics by taking square roots. So make sure you put today's date in the upper left hand or right hand corner. And let's just kind of quickly review what we did last week. So if I gave you this equation and I asked you to solve it, I said x squared equals 9. Using a graphing calculator, we were able to graph this and take a look and see where the two equations intersected. So I'm just going to tape this in really quick. And then we'll sketch a quick graph of that on our calculators. So take out your calculators. And we're just going to do what we did before by solving by taking the graph. So we get y equals. The left-hand side was y1, so I'm just going to type in x squared. The right-hand side was y2, so I'll just type in 9. If you have to clear out something in those calculators, just clear them out. And then type in the appropriate equation for each line. All right, so we had our graphs, our equations that we entered in. We're going to graph it by pressing graph on the top right. And there's the x squared, and there's the 9. So I'm going to sketch this graph on my paper. It's not to be perfect, I'm just kind of getting a sketch of it. And then I'm going to draw a line through 9. Alright, so before we were able to identify the two solutions were where the two lines intersected, the two graphs intersected. And to do that on our calculators, we just had second, trace, and we went down to number 5, intersect. Once we did that, we just moved the cursor towards each intersection point and hit enter 3 times. So here I knew that one of my solutions was x equals 3. Doing that again, we repeated the process because there was another intersection point, so we had second, trace, number 5, intersect. We moved over to the left, moved our little spider cursor, and press enter 3 times. So the other solution was x equals -3. That was solving by graphing. So that was a quick review of what we did last week. Today I'm going to show you how to solve this equation algebraically. And what you might not have been able to connect last week, or you might not have realized, is that this answer, when you plug it in, should be the answer to the other side of the equation when you do the work on this side of the equation. So when I plug in 3 here, 3 squared is 9. Or when I plug in -3, -3 times -3 is also 9. That's why there's 2 solutions here to this equation. So when we're solving by taking square roots, we're going to look at those same equations, but we're going to do them algebraically instead of by graphing. So if I gave you that problem again, x squared equals 9, I know what the answer is already because we solved it by graphing, but I just want to show you how we do it by solving by taking square roots. So remember, square roots is this symbol. So when you square root something, you're asking yourself what number multiplied by itself gives you that number. So again, we're trying to figure out what number multiplied by itself gives me 9. So on your calculator, the square root symbol is just above the x squared. You got to hit the second key first though. So if I want to get the square root, I hit second and then x squared. So then it gives me that symbol on my calculator. And now I can just type in 9, the square root of 9. So the square root of 9 is 3. So I know one of my solutions is 3. So what you have to be careful of is that when you're square rooting an equation with the x squared, you also have to think of the other possibility, which is the negative version. So x equals 3 or x equals negative 3. So when you're solving by taking square roots, you're essentially just undoing the equation, and the undo of the square is the square root. So let's look at a little bit more complicated of a problem. Let's say I gave you this problem. 4x squared equals 64. Before I can take square roots, I have to get the x squared by itself. And notice the difference from this week and last week's problems. In this week's problems, there's only an x squared term. There's no x by itself in this equation. So that's why we can take square roots, because we're just looking at the x squared term. So to undo this, I want to get the x squared by itself. So to get x squared by itself, I have to undo what's happening to it. This means multiplying by 4 when it's in front of it, so I have to divide both sides by 4. So I've got x squared equals 16. And now to solve that, I just take the square root of both sides. So either x equals 4 or x equals negative 4. Because you have to think of the two solutions that you could multiply together to get to 16. 4 times 4 is 16, and negative 4 times negative 4 is 16. And then those are your two solutions. Remember, another method we've learned is solve by graphing. So you could enter this onto your calculator and solve this equation, and you would get to x equals 4 and x equals negative 4. Let's take a look at another example. Let's say I gave you 2x squared plus 5 equals 55. All right, so I want to solve this by undoing and getting x squared by itself. I want to turn it into this type of equation so I can just take the square root. So I have to undo what's happening to this x squared. So the first thing I would want to do is subtract 5 on both sides. Because now this cancels out, and I get 2x squared equals 50. From here, we're going to continue to undo. So I'm going to divide both sides by 2 and get x squared equals 25. And now that the x squared is all by itself, I can take a square root of both sides. So either x equals 5 or x equals negative 5. And that's solving by taking square roots. Let's look at one more example. Let's say I gave you 3x squared plus 10 equals 46. We're going to follow the same steps to undo. We're going to subtract 10 on both sides. So I get 3x squared equals 36. Divide both sides by 3. X squared equals 12. All right, so now this one's a little bit trickier because this number now is not a perfect square root. So this is a new type of answer that you're going to see that we're going to be comfortable working with. We're going to be working with the radical answer. So if I square root both sides, you can square root 12, but it gives you some weird decimal. Let's see. If I do the second square root of 12. That gives me that long decimal. I don't want to deal with decimal answers. So the way that we write this, you say x equals the positive version of root 12, or x equals the negative version of root 12. And another way that mathematicians write this is they'll say x equals plus or minus the square root of 12. You could also use that for your other answers. For here, you could combine this and say x equals plus or minus 5, x equals plus or minus 4, x equals plus or minus 3. So when we're dealing with these quadratics, in a lot of the situations, we're going to have two solutions, the plus or minus of that version. And sometimes our answers are not going to be perfect squares, so we write them with the square root, such as number 4. So that's another way of solving quadratics when we only have the x squared term. So we know how to solve by taking square roots, and we know how to solve by graphing. So those are two methods you can use to solve for square roots. So you're going to practice these more this week.